All right, so during lecture today, the last few minutes or so, the video got a little bit blocky. So that's what we're just kind of correcting here. So we're just redoing the last few examples just in case you may have missed anything. So really no new information here. Everything that we're going to do is in that main lecture video. Just it might get a little blocky here or there. So if that's an issue for you, you can see what we did here. All right, so what were we doing? Well, we were doing the derivative of these basic functions, and in this example in particular, one's involving e to the x and natural log. And in both of these, we have a term that's going to present a bit of an issue. So in that first function, we have 5e to the x. That's not going to be a problem. But we have x square root x. That one's going to be a little bit of an issue, and we're going to have to deal with that. And then in the second function, we have the function h of t equal to t squared plus 1 over t plus 7 times natural log. And the 7 natural log, that's going to be fine. It's that first term that's going to present us a little bit of an issue, and it's because it's a fraction, it's a quotient, and we haven't seen yet how to handle quotients. And in that first one, we have x times square root x. We have a product. We haven't seen how to handle products. And so the idea for both of these is to rewrite that term that's giving us an issue as a power function if possible. And it's going to be possible for both of these. So for that first one, we have x times square root x. How can we rewrite that as a power function? Well, we really have x to the power 1 times x to the power 1/2. And when we have power functions multiplied together and they have the same base, so in this case they're both x's, we just add the exponents. So we end up with x to the 1 plus 1/2, and if we simplify, we get x to the 3/2 power. So cleaning that up a little bit, rewriting that function, we have 5e to the x plus x to the 3/2. And we see that we have that power function now. So this is something we're going to be able to do. Let's go down to the other function, though, while we're in this mindset of rewriting things as power functions. And let's see how we can deal with that fraction. So we're also going to rewrite this first term. That's going to present a bit of an issue. We're going to rewrite that as a power function, or maybe a couple power functions. And the idea with a fraction is we can split the fraction up into multiple fractions based on wherever we have a plus or a minus in the numerator. So we could write this as t squared over our denominator, so t squared over t, plus, and then the other term we had in the numerator was 1, so we're going to have plus 1 over our same denominator, 1 over t in this case. So if we keep going, we can get each of those as a power function. So the t squared over t just becomes t. The 1 over t, we can write that as t to the minus 1. And now both of those are power functions, so we know how to handle those. So let's just fill that in. We get t plus t to the minus 1 plus 7 natural log t. And now we'll see how to deal with that 7 natural log t. That's not going to be the issue, but we've rewritten that fraction, so now it's something we can work with. All right, so let's actually see how to do the derivatives. So in this first one, we're going to calculate g prime. So let's write down our function. It's 5e to the x plus x to the 3/2 power. We're going to differentiate term by term. So in that first term, the 5e to the x, we're going to apply the derivative to the variable part. So we'll apply the derivative to e to the x. 5 is a constant, so we leave it outside of the brackets. Then we go to our second term, apply the derivative to the variable part. So we'll apply it to the whole thing in this case. And then we go through and differentiate. So 5 is a constant multiple. It's outside of the brackets. We just kind of leave it be. E to the x, we go to our table, look up e to the x, and the derivative of e to the x, well, it's nice. It's just e to the x. So we fill that in. And then for the last term, that's just a power function, so we use the power rule. So 3/2 x to the 1/2 power. And there's our derivative. All right. What about that other function where we had a natural log? We want to calculate h prime of t. So let's write down our function. It's t plus t to the minus 1 plus 7 natural log of t. And we've gone through and rewritten that. We'll go term by term, apply the derivative to the variable parts. So we apply the derivative to the first term, we apply the derivative to the second term, and then in the third term, we're going to apply the derivative just to the variable part. So we're going to apply it just to that natural log. The 7's a constant multiple, it stays out in front. And then we differentiate. So derivative of t is just 1. Derivative of t to the minus 1 is negative t to the minus 2. So we're using power rule there. And then we have plus 7. And we want to differentiate the natural log of t. So we go to our little chart here. We look up the natural log function. And then we see that its derivative is 1 over x. So for our purposes, derivative of natural log t is 1 over t. So the derivative here ends up being 1 minus t to the negative 2 power plus 7 over t. All right, so just a few more basic derivatives, this time using exponential and log functions, and then also a more complicated term that we had to kind of do some arithmetic with. Do the rewrite as a power function, so rewrite that product as a power function, or rewrite that quotient as a couple power functions. All right, in the last example, we're just going to see how this process works with doing second derivatives and evaluating derivatives. So in this one, we have the function s equal to t cubed minus 2t squared plus 3t. And we're going to find the first derivative, the second derivative, and then we're going to evaluate each of those derivatives when t is equal to negative 2. All right, so let's start by calculating the first derivative. So we're going to calculate ds dt, and we're just going to go term by term. So derivative of t cubed is 3t squared. Derivative of the second term of the negative 2t squared is negative 4t. And then the derivative of our third term, derivative of 3t, is just plus 3. So we just go term by term and differentiate. So that's our first derivative. Brand new function. We want the second derivative. So what we're going to do is we're just going to take that first derivative we just calculated and we're going to differentiate that. And that'll give us our second derivative. So if I look, first term is 3t squared. I want to do the derivative of that. I get 6t. Then I look, my second term there is negative 4t. I want to do the derivative of that. I get negative 4. And then finally, I look at my third term. It's the plus 3. That's all by itself. There's no variable there. So when I differentiate the plus 3, I get 0. So our second derivative ends up being 6t minus 4. All right, so we've calculated the first derivative, calculated the second derivative. Now we're going to evaluate both of these at t equals negative 2. So what does that look like? Well, we write ds dt for our first derivative, and then that vertical line means evaluate, and then we put the number that we're going to evaluate at, so t equals negative 2. All right, so we rewrite our first derivative. And then wherever I see a t in my original derivative there, I'm going to replace that with the number negative 2. So I get 3 times negative 2 squared minus 4 times negative 2 plus 3. Do some of the arithmetic. I get 3 times positive 4 plus 8 plus 3, which ends up being 23. So that's what we get when we evaluate the first derivative. When we do the second derivative, we write down the name of our second derivative. Vertical line means we're going to evaluate, and then we put the number that we're going to evaluate, so -2. And then we write down our second derivative, and instead of putting variable t, what we're going to do is we're going to plug in -2. So wherever we see a variable, we see variable t, we're going to change it to number 2, -2. So we end up with 6 times -2 minus 4. Doing the arithmetic there, we end up with -16. All right, so when we have our first derivative, when we have our second derivative, those are functions. And then when we plug in -2, we get a number out. So we're just evaluating. So when we evaluate a function, the result ends up being a number. And so in this process of differentiating and then evaluating, the order kind of matters. So we differentiate first. And then we evaluate second. So you have to, if you're going to evaluate the derivative, well, you first need the derivative before you can start plugging numbers into it. So you have to find the derivative or find the second derivative first, then you can plug into it. All right, so that was just to cover the last few minutes of lecture in case the video feed cut out and it was a bit distracting for you. So again, no new information here. This is all covered in the main lecture. So, just in case the video cutting in and out was a little distracting, you have the complete set here. All right, we'll see you next week. Bye-bye.